Thanks so much for coming for the second day. For the ones that are coming for the first day, welcome. We're directly from Almonin family. We're really glad to hold that event, and thanks Sebastian to make it happen.
Thank you for organizing everything.
We are delighted to have Annika and Sophia playing some pieces for us. So it's something slightly unusual that we wanted to introduce to our conference meetings. So as I said yesterday, it's a place for us to discuss and to express the best we can. So thank you so much, Harris, for coming for this second day. Yesterday we had a great workshop with him, and I think the ones that came had I think very special moment because it's not something we see normally. Just at group meetings discussing about the, the subject. But I think we are here to develop, so we'll be more than we are more than welcome, and we will thank if you can give us feedback on these days we are passing together. So for the next one, we can make it better. As I said yesterday, we're more than happy to interrupt in the middle of the meeting with the conference. And also, if you need any coffee, the bathroom is right there on the right. And
For the coffee?
also the coffee, yeah, the coffee. You know,
The coffee is here, bathroom there.
And yeah, I think that's it.
I'd like to introduce Charis. He works in the Queen Mary University of London. 10 years already? Five, okay. Making PhD in McGill in Canada. He worked with Claudia for a bit in violins back in the day, and now my plan is to bring him to the dark side and seduce him into studying these beautiful instruments. Please go ahead.
Thank you.
There are seats here.
Okay, yeah, great. Very happy to be here, and I want to thank Sebastian and Gayan for inviting me. Indeed, as Sebastian just said, okay.
Can you take this off? And you don't like
That's a little better. Yeah.
something?
Around, how much is it now? Maybe 12 years. So between 2008 roughly and 2013, 14, I was at McGill University working with Gary Scavone on what was initially going, sorry, a little bit louder, of course, on something that was going to be about violin acoustics and modeling, but we very quickly got interested in questions of, how do violin players evaluate the quality of the instrument? What is it that they like? What is it that they look for? We worked also with Claudia Fritz, so I will be presenting some stuff from that era that I think can be of interest, and also within the broader context of timbre, which is kind of the focus of my post-PhD research. This work that I did with the violins, inevitably, I think we discussed that yesterday at some point during the roundtable. Inevitably, it's a very complicated matter. There's the sound of the instrument, there's also the haptics, the vibrational behavior, the player feels, all that. So this led to some interesting collaboration with Stefano Papetti, who is based in the Zurich Hochschule for the Arts. And we edited a book on musical haptics. So bringing together a variety of research on the interaction between the auditory and the haptic modality in music. And then I did the mistake of agreeing to edit another book. generally editing books, working with other academics that they have to meet deadlines. It's a terrible task. I'm terrible with deadlines as well. So, however, we managed to also edit the sort of first authoritative state-of-the-art in psychoacoustical research on timbre. So together with Kai Zinnenberg, who also does research on that area, and Stephen McAdams, who is kind of one of the major researchers in timbre and musical sound. In parallel, together with Kai Zinnenberg and Asterios Zacharakis at the University of Thessaloniki, we co-founded, let's say, a new interdisciplinary conference, a meeting, which we try to hold every 3 years approximately. There was first a big conference on timbre that happened in Canada in 2018, organized by Stephen, and then we sort of decided to make this a more frequent thing and to try to bring together different disciplines involved with timbre: musical acoustics, psychology, neuroscience, audio engineering, and so on. So our last one was last summer in Thessaloniki, and the next conference is going to be in 2026. We're not sure yet where, possibly in London, but might not be there. And then what I've been focusing lately, and why I accepted the invitation to come here and sort of go a bit back in that era, as Sebastian said, is that I've been thinking a lot about the sort of traditional psychoacoustical research about sound perception and timbre, how it is a bit confined, like in laboratory experiments with isolated sounds that we play to listeners. The sounds have no context. So it's a very static, let's say, approach. It's a great paradigm. We've learned a lot about timbre and human perception through this research, but there's more to timbre, as I hope we can see a bit today. So my question recently is, how is timbre used and understood in creative practice? For example, when we design instruments, when we design tools for makers, whether it's for traditional makers, luthiers, or for digital instrument makers, like people who make synthesizers or other kind of weird interactive digital systems. And this is something that eventually we kind of need to look at what lies between the creator, whether it is the maker, whether it is the composer, the producer, and the receiver, the musician who plays the instrument, the listener who listens to the music. And that is technology. So that's why I'm sort of focusing on that. And technology is not only digital stuff or AI, which is kind of the thing nowadays. Instruments, right? So this violin, this cellos here, these are technologies as well. And Dana Goulet very nicely said in a paper from 2013 that instrument and timbres are actually what happens when a person encounters the technology. And I think that it doesn't answer, but I think it gives an interesting perspective in a lot of the things that are constantly being discussed in the community and between like makers and scientists. You have somebody and they play an instrument, and that's when timbre happens. We can try and quantify some aspects of it, but there's a lot of other aspects that we might not be able to quantify. So this is kind of like my background, let's say the context of this presentation. So of course I've been talking about timbre and what is timbre, and for those of you that were at the workshop yesterday, we tried to create some let's say common understanding. In research, and particularly in acoustics and psychoacoustics and psychology, there has been an attempt for some sort of standard definition So ANSI stands for the American National Standards Institute, and ASA is the Acoustical Society of America. So they try to, in the same way that there is some sort of standard definition about pitch and about loudness, they try to create a definition for timbre. And the sort of obvious idea is that if you have two identical sounds, two sounds that have the same pitch, or if you prefer, they are played at the same fundamental frequency and at the same volume, and you try to qualitatively compare them, kind of everything that remains outside pitch and loudness perception is timbre. And we will see actually that this definition has its roots in the 18th century. Obviously, at some point, they added the second sentence because, and we are going to also see some of these aspects as well, timbre depends or interacts with fundamental frequency, right? So a low pitch creates a very different spectrum than a high pitch and so on. And what is high and low differs between instruments and so on. There is dynamics, different playing techniques. So timbre interacts with all these elements. So because of this definition, researchers have called timbre the wastebasket. So we like to complain about this definition, but it's kind of the best we have, let's say. So it has been called the wastebasket in the sense that anything that we cannot explain through theories about pitch, loudness, and even timing, like rhythm perception, we try to attribute to timbre. Indeed, the two major scientific methodologies for studying timbre approach it as a multidimensional thing, and they try to kind of like understand its major constituents. Of course, I think we all share this idea here through your making practice and also through your interaction with players that this is simply not the case. In this wastebasket, there is like a rich abundance of musical expression. Timbre can mean different things to different people. It can have different functions. We sort of saw yesterday, simply by doing this workshop, that for different teams and for different individuals, the concept of timbre had different significance, different connotations. Daniel Villegas Velez has written that in this wastebasket, we basically keep discovering elements in sounds that we do not initially notice or anticipate. In a way, I feel that with, I remember back then in my PhD doing a lot of interviews with violin players, and probably the biggest, the most important thing for them was that their instrument has a rich sound in the sense that it eventually allows them to create a lot of different timbres and different nuances, even things that they might not have expected in the beginning. And we will come back to the concept of violin richness later. So then to work with timbre, for me, the interpretation of these ideas is that we need to constantly negotiate and redefine it within musical experience or sonic experience. And this includes performance practice, working with musicians, but also musical craft practice, like working with people that make technologies for making music, and that includes instruments. The second sort of major issue here then is, okay, we have timbre, and then there is, how do we talk about it? How do we discuss timbre? A question you can ask somebody is like, play them something like, how does it sound to you? when in Barton's biography of Yehudi Menuhin, he writes about how Menuhin used to describe his Heaven-Hüller Strat, which I believe was here last year or something like that. I learned last night. So he describes the instrument as ample and round. Clearly that refers to the sound, right? I mean, the instrument itself as a physical object, it's not ample. And, you know, the sound is also powerful, mellow, and sweet. You know, what is a mellow sound? What is a sweet sound? Perhaps powerful is an easier kind of like metaphorical description to understand in terms of energy. But these other words like mellow and sweet, which they seem to be related more to, you know, how we taste food or other flavors. Where do they come from? So we do use, and you know that, and that's one of the major issues in violin making and communicating with your clients, that we use a diverse vocabulary to communicate sort of timbral qualities. What's important to know is that this vocabulary, these metaphors, are not crucial for perceptualizing timbre. So the way our brain can interpret, the way we can perceive sound, as in, you know, the sound waves arrive in our ears and then they get transformed into neuronal activations based on the cochlea and all that. This is something that happens anyways, and you can remember a sound, a noticeable sound or a terrible sound. You can recognize the source of the sound, that this is a glass breaking. You can recognize steps approaching from the back and so on. Yes?
In general, when you remember a sound, do you remember the word for the sound or the sound itself?
It could be both, but you don't necessarily need to remember the word, or you don't need to describe the sound you're remembering.
But personally, I cannot remember any sound. I cannot put a word to it.
What word though? Are you talking about a word like mellow or
just like an object? Like,
yeah, that's different.
Okay.
Yeah, actually, that's a very good point. So throughout this talk, I will be talking about timbre semantics, right? Semantic descriptions of timbre. Strictly speaking, saying that this sound is a violin is also a semantic description of the sound, right? The sort of source recognition, the object recognition. But traditionally, in the kind of research that I'm going to present, we consider timbre semantics to refer to these more abstract descriptions of qualities. So these are important to conceptualize timbre. So the role of these metaphors, of these terms, are essentially to allow us to communicate subtle acoustic variations through more like commonly shared sensory experiences. Because also we don't have a sensory vocabulary for sound like we do for flavor, for touch, for vision. So we rely on these descriptions to conceptualize, to understand through lived experience the sound, and communicate it to, you know, between us, to our clients, to our colleagues, and so on. An interesting work I came across by Courtney Reed, we've also been doing some work together lately, so she tried to kind of come up with a model of metaphor communication, and she focused on voice lessons, right? So the relationship between the voice teacher and the voice student, because she also practices vocal performance as well. Starting from a model from a thesis by Dunbar Wells in 1997, where we can see the idea is that, the teacher has a metaphor that they use, and then the student, when they hear it, this gets translated in some sort of sensory-based imagery. It is internalized. This means that gradually the brain learns to associate specific sounds, specific acoustical cues with this metaphor. Then this can be mapped to actually physical adjustments. So the person learns then, okay, to make my voice brighter, I need to, put my lines a bit higher or something like that. And then, this gets constantly updated. And the reason I thought this would be interesting to present here is that I think this is how metaphor operates more generally, and especially imagine that the teacher is your teacher of violin making, or the person you learned to make violins with, and you are the student, or you are the teacher, and you're teaching the next generation of violin makers. And then in the through her own study, Courtney proposed a more refined, let's say, version of this model where, we have the teacher and the student. They both have some cognitive understanding of the sound and the metaphor, and then through the metaphor, they encode and decode constantly in a sort of constant loop in order to arrive at some sort of mutual understanding. And so metaphor is very useful in negotiating information between individual lived experiences. This doesn't mean that the metaphor is perfect or that there is a lot of differences and individual differences, as we discussed a little bit yesterday. But the role of metaphor is there to enable, convergence towards a mutual understanding. Yes.
How cultural is this? Because talking with Thomas, for example, how he learned to play samba, and so he went in the bar with his father, and he would be in the ronda and just start doing it in a very non-linguistic way. Is this like a general model, or
No. This is
based?
I wouldn't say this is a general model. Both the studies are about voice lessons, and I think both were done in with within the UK, let's say, context. No, I wouldn't say it's very general, but I think the second, both of them kind of approach the general sort of metaphor theory. For example, Lakoff and Johnson, if you're familiar with their work on metaphors we live by, and this is where I borrow the title of the talk. Metaphor is supposed to be cross-cultural, like there is this idea. The metaphor doesn't have to always be verbal. Maybe that's a better answer to your question.
Yes.
So the metaphor can operate in other modalities. And I think some of for example, in the workshop yesterday, some people talked about creating some circle and visualizing a bit some of the processes to communicate their ideas. Any other? Okay, so let's go a bit back to timbre. Basically, I will try to make the point that timbre and metaphor have been basically together from the beginning. It was kind of inevitable. Emily Dolan, you might be familiar. She's a musicologist, and she basically traced the first kind of attempt to define timbre as a distinct third property of a sound, in addition to pitch and loudness, to Jean-Jacques Rousseau's entry at the Encyclopédie. So this was published in 1765, but she did some research that shows that probably he had written this around 1749. First of all, he originally used the term timbre with a Y, referring to timpani and the sort of Greek word about timpano and the sound that it makes. What he does is he basically defines timbre along two dimensions. So there is harshness or softness and dullness or brightness. So he can't escape, like he has to define timbre through these metaphorical ideas. And we will see in a bit perhaps why that was the case. He gives some description and even some more aesthetical ideas that the beautiful timbre is the one that combines softness with brightness, etc. And the violin is an example, of course. It is always considered, I don't know, the beautiful or the most beautiful timbre in the orchestra. And the origin of the term actually is French, timbre, like stamp. And what I find interesting is that so all the sort of Latin languages very quickly adopted that word. So in Spanish, in Italian, the word timbre is used. But other languages, like in Greece, Germanic languages, they have retained a different word for timbre, which is sound color, so Klangfarbe, or ichochroma, if you know Greek. Ichos is sound and chroma is color. Eventually, though, the word timbre kind of dominated, and at least in science, that's the main term that is being used. Or if you prefer, in Anglophone science. If we go even further back, in the Otibilibus, which was initially thought to be written by Aristotle, but possibly through some of his students, etc. They had written that the brightest sounds are those that are best able to move the sense of hearing when they impinge on it. There was a way that people were able to negotiate, to talk about these intangible qualities of sounds, right? Something that is not related to the pitch or the volume of the sound, but something more, I don't know, esoteric, the character of the sound. So they were able to do that through metaphors, essentially, and brightness was always kind of at the center of this. Even before the encyclopedia with Jean-Jacques Rousseau's article was published, it was used, for example, in the Dictionnaire de Trabou. The word timbre was actually connected specifically to the bell, to cowbells and carillons, and also the word bright appears as well. So describing tone quality was relied on other sensory experiences through metaphorical language, and that was way before timbre came into music and discourse through Jean-Jacques Rousseau. Following Jean-Jacques Rousseau, that kept being the case constantly. So that people were talking about distinguished sounds, and there was always the metaphor there about soft, sonorous, brilliant, sharp, penetrating, tender, you name it. I think yesterday at the workshop we also heard some very interesting crazy metaphors from the teacher of one of the participants. If we want to put some context then into where do these metaphors fit, we can think a bit about broader theories about musical meaning. So music and musical sound can have meaning. There is Stefan Koelsch, a neuroscientist, has proposed there's three broad categories of musical meaning: extra musical, interpreting musical sound through non-musical concepts. There is intramusical, which is the interpretation of structural references inside a piece without any extra musical associations. And then there is musicogenic, which is about rather than interpreting musical cues per se, we interpret the sort of physical responses to that. So, dancing to music is kind of a musicogenic meaning. So there are three types of extra musical meaning. There is iconic, which is about qualities of objects and abstract concepts. So you can kind of guess where about the timbre metaphors are going to fall. There is indexical, which is about emotion and intention, recognition in music. And finally, there is symbolic that has to do with social and cultural association. So, for example, hearing, I don't know, the national anthem of your country and feeling patriotic. And so timbre metaphors are essentially iconic extra musical references to in musical experience. And the way we talk then, how can we try to organize a bit all these different metaphors? Like what types of discourse are below them? So there was an interesting work by Porcello, kind of an ethnography on sound recording engineers, primarily in the south of the United States. Interestingly enough, audio engineers they always try to standardize this vocabulary, much more, I think, than acousticians. There's even a couple of attempts I think there's a book, at least, I know one book by somebody named Hope, who tried to basically create an audio vocabulary and standardize it as much as possible. And if you Google online and you go to different forums for audio engineers, audio technologists, they always try to, okay, brightness is that, softness is that. They haven't really arrived at a standardized lexicon in the sense that winemaking has, but they are trying much more. So that's why Porcello looked at that community and tried to understand the kind of linguistic devices they use. And he considered, their spoken sound vocables like, wah wah, describing the effects pedal, lexical onomatopoeia. So when you say that this violin has a very ringing sound, essentially you use onomatopoeia because you refer to the sound of a ring. Pure metaphors like mellow, sweet, sharp, bright. Association, so this sounds like an Italian violin or a German violin. And also evaluation, which is more about affective terms like, oh, this is a beautiful sound, or this is an interesting sound, and so on. And then much later, Zachary Wallmark he analyzed all semantic descriptions across 11 major orchestration textbooks. And he proposed that the categories are largely these, where essentially he combines vocables and onomatopoeia in a single category, and then he kind of gives a bit more fine-grained categorization for metaphors in terms of whether it is matter, for example, density, or whether it's more cross-modal associations like bright, velvety, not velvety, mellow. Velvety would be matter. Acoustical kind of metaphors, in a way, loud or soft could fall under there, and more action stuff. We will see some examples of this shown. And then he used some statistical tools to try and see if these categories had a more, let's say, latent, a more low-dimensional structure under them. And he found that essentially the way these semantic descriptions were used in these orchestration books, they were largely about material, about sensory experiences, and about activity. So scratchy or raspy sound would be more in the sort of activity realm. And this is essentially what in both these works is considered like, the core idea of metaphor in timbre. Porcello deducted that, he noticed that this is very codified, especially among musicians and sound engineers. So despite, the challenges and that we might mean different things with the different terms between us, it is somehow a codified way of communicating timbre qualities. There is an interesting quote by Nikolai Rimsky-Korsakov that it's difficult matter to define tone quality in words. We must encroach. It's not even we can or we could. We must encroach upon the domain of sight, feeling, and even taste. So building then on this idea of conceptual metaphors coming from linguistics, we can think of metaphors as indexes of conceptual representations that are grounded in perception and action. Zachary Wallmark, in his thesis, proposed three conceptual metaphors to explain the majority of timbre metaphors. So first of all, instruments are voices. So we think of instruments, we describe instruments like we would describe voice. Nasal, holding, open. We think of sound as material. So it's belt-like, it's metallic, it's hollow, it's velvety, and so on. And there is, of course, a category about more noisy type of timbres and sounds, harsh, rough, shrill, where there the central metaphor underlying all this seems to be noise is friction. The idea here is that we can think of these three conceptual metaphors as embodied, as part of embodied cognition. So this account is essentially, it talks a bit about that, an embodied perspective on timbre. Especially the way we, so in voice perception research, there is a theory about how our perception of voice, of other people's voices, really comes from how we understand our own production of voice, right? So in order to speak, I understand gradually as I grow up that if I want to make a high-pitched sound, I have to increase my larynx, like put it upward. If I need to make a more low-frequency sound, I need to lower it. Through understanding how we produce sound ourselves, we understand the voices of other people. And I think this is something that probably extends more broadly to how we perceive sound in the world more generally. So there is probably a relatively direct connection between our bodies and the physiology of our own voice with how we understand sound more broadly and why we use these metaphors. Then going back to psychoacoustical research then. Right. So what I presented so far, I tried to sort of give a more kind of like theoretical foundation about timbre and metaphor, and now I will present some major results in psychoacoustical research about timbre and these semantic terms. So of course we have Helmholtz, who with his instruments that were making, he was combining harmonics and all that. He was able to, he proposed some specific correlations, let's say, or relationships between terms and frequency relationships, then Stumpf, another German acoustician, he actually addressed that issue. He said, there's a lot of verbal attributes out there, but we could probably, if we consider the semantic proximity of these terms, we could probably say that all of these words that describe timbre can be summarized as about brightness, about roughness, and about fullness. And actually, we will see in a bit that this is what most studies converge to. There was also some research by Lichte in the 1940s where he actually tried to do listening tests based on Helmholtz's suggestions. And he even went as far as to say that, okay, brightness, roughness, and fullness, we can consider them actually independent attributes of sound. Different versions, different constituents of timbre. And from the 50s onwards, we have Osgood proposing the semantic differential method. The idea that I can give you a scale that either has two opposites, like bright and dull, or rough and soft, or I can give you a scale where it has the positive on one side and its negation on the other, bright and not bright. And I can play you some sounds, and then you select where to place the sound in that scale. By doing that for several sounds and for several scales and with several listeners, we can then apply dimensionality reduction techniques like factor analysis, for example, or even principal component analysis, you might be more familiar with. And that eventually get us to what we call a semantic space. So a smaller number of dimensions that explain all the different ratings across the different scales. And so using that method, first von Bismarck suggested that the major semantic dimensions of timbre is dual sharp, compact scattered, full empty, and colorful colorless. The interesting point here is that he was using the term sharp, but sort of equivalent to what we call brightness in English. So there's this interesting point where in Germanic languages, scharf is used for timbre, but in English, sharp is mostly about pitches. It's not really used very much to describe timbre. We have then the Zaharaki study that sort of found this kind of again, 3 dimensions, sort of cross-cultural. So they had an Anglophone set of listeners and Greek listeners as well. And then more recently, Raymore and Harron, they sort of did this very big study where they had a lot of musicians describing sounds of instruments, they proposed 20 dimensions actually, so kind of a larger model. I think some of them, you could argue that you could try and summarize them towards the 3 dimensions, but it's quite an interesting idea. And then, so yeah, putting it together then, these are the different discourse strategies, the conceptual metaphors by Wallmark, then the semantic dimensions that have arrived from psychoacoustical research, and finally, we have cross-modal. There is some sort of cross-modality going on because a lot of these metaphors have to do with how we experience material and things in other senses. We did a study recently. It was published last year, I think, with a bunch of colleagues from the Actor Project, which is based at McGill University, and we actually tried. We used 8 instruments. We had notes at 3 registers and 2 pitch classes. You can see that below there. And we used the 20 scales from the Raymore and Harron study. So we had a large number of people online rating these 24 sounds on these 20 scales. And what we found is that there is actually an influence. So, and that's, I think, of interest to you. So within an instrument, for example, I think the violin is here. So if you look at the scale that is described by smooth or singing or sweet, the middle register was rated higher than the other two. So whereas for the and the cello had kind of a similar pattern, but for brass instruments like the trombone, or here we have the bass clarinet, which is not the brass, of course. The trends are different. So on the other side, we have the brightness, let's say, scale, where it's very clear that, of course, as we go up in register, we get more brighter sound. So and we quantified that. This is the association of the register. So statistically, indeed, for most of these scales, the type of instrument and the register on which the note was played influenced the ratings on these semantic scales. So it's not only that bright might mean different things between person A and person B, but bright changes a lot within a single instrument playing at different registers with different techniques and so on. When we tried some hierarchical clustering, actually we saw that pitch, not register, pitch height actually explained better what was going on, which confirms a lot of research about how pitch and brightness, how pitch and timbre interact. So yeah, again, statistically confirmed here with some models that we ran where the pitch height models explained more variance in most of the scales. We also, I did some study recently, it was published a few months ago with Zachary Walmark, where we tried to look at interactions between pitch and brightness. So we had sounds that varied in either pitch, fundamental frequency, and centroid. So I can quickly play some examples. So the first would be typically considered dark and the second bright. So we had this task where you would hear two sounds. The target had either a higher centroid or a higher pitch, or the other way around. And we asked, is the target brighter than the baseline, or is it higher? So we have two tasks, one comparing brightness and one comparing pitch height. And the results basically show strong interaction in both tasks, so confirming previous literature. So basically, whenever we had incongruent matches, right, we would ask you if the sound is higher, but we would play you a lower pitch or darker sound. The reaction speed and the error rate would, the reaction speed would decrease and the error rate would increase. This is a classic paradigm in experimental psychology. It's called the speeded classification test. So by doing things very quickly, you can, and by looking at reaction times and error rates, you can understand if people, if one perceptual dimension can influence another. So generally, there is interaction between pitch and timbre, and specifically with brightness, which is one of the major timbre or semantic dimensions. I probably don't have time to go more, but I can quickly mention, so in my PhD, I worked a lot with what we call free verbalization tasks. So we talk with musicians, they give us their, it's like, let's say, interviews in a way, and then you try to find micro concepts in the interviews and try to understand more shared categories. So to give you a quick example, somebody would say something like that: comfortable sounds interesting with enough complexity, variety of sounds with ease, quick response. You then start grouping this in similar categories. And finally, we proposed in one paper this kind of model about how sound information and haptic information from the instrument can map to some very high level, let's say, semantic categories for the violin. Then in some subsequent research, we found that richness was actually a very important parameter, a very important attribute, and it explained preference for violins. So what we did then is we we did an online survey and also a playing experiment where they had to do some stuff, and then we asked them specifically about richness, and these are some of the stuff we got. So the difference between butter and margarine, or I judge richness based on how much the sound reminds me of melted chocolate. So these are actually things that people told us in this study. I categorize this again. So richness seems to be about fullness and complexity of the sound, also about warmth and mellowness. It's about having a more focused sound, vibrato. So there is one single word like richness, right? So it can mean a lot of different things. So that's, I think, important for craft practice. Yeah, so I think I don't have time to talk about that. This is some recent work that we started with Montserrat Pamiesvila in Vienna. So we look at non-ordinary bowing techniques, and we try to look a bit at how people describe the sound of these techniques, which is, it goes more towards the area of noisy timbres, and it's quite interesting. And it seems to be in line with existing research on noise-related timbre semantics. And Montserrat has been doing some analysis with audio descriptors, like extracting information from the audio signals we recorded and try to see how they explain the descriptions. So we have found some results, and I think she's collecting some more data right now, and we hope to publish a more comprehensive paper soon. But is this the? Yeah. So we have found that this, like the average energy in the sound and the noisiness, seem to explain some of these definitions. Yeah, so it's a study where we try to see both semantic descriptors, but also Montserrat is more interested in the acoustics of extended techniques. That was a video, and I think that's it essentially. Ignore that. Yeah, this is some stuff we've been doing. Actually, I want to quickly. Oops, sorry. So we collected a large set of data online through some sort of little game where people had to navigate a synthesizer space and stop where they thought there is a bright sound or a dark sound or a velvet, etc. So a very noisy data set, right? We didn't really curate it very carefully, very scientifically, let's say. It was more about some public engagement activity. But we then looked at the data, and what we saw is that we can actually predict quite well the arousal of the semantic terms. So in linguistics, there is this concept where every word, especially descriptive adjectives, like these metaphors, it has some sort of affective meaning as well. So the word bright is more about happier emotions, higher arousal, let's say, in valence, whereas dull has low valence and low arousal. And there is linguistic work where there are norms. So there is data about how much valence or how much arousal each of these terms has. So we used such a study. So rather than predicting, from the audio and the acoustics and the synthesizer parameters, our words, the semantic words, we tried to predict their affective norms. And actually we found that we could predict arousal quite well. Valence too, but arousal was even better and actually statistically significant. So this is a final comment, if you want, that behind these terms, bright, sharp, rough, there is much more. There is also emotion and affect. And this is something that is still not fully explored, neither in our domain, nor also in the broader domain of multisensory perception. Okay, so I think that's it for me. Thank you so much.
What's the best way to follow your work? And could you possibly suggest a reading list to go deeper into the concepts that you've described here? And lastly, are you willing to share your slides?
Yes, of course. I'm very happy to share the slides. And
The books of abstract we have, the book of abstract, we have all the literature.
Okay.
yeah, so some literature is provided in the extended abstract I had sent. And also, this is the website of my lab. So we have all our publications there. You can have a look.
Also, the live was recorded, so it's on our YouTube channel. If you want to check out again, it's all there.
I mean, I think it would be amazing to have a reading list for makers.
Yeah, that's a great idea, actually.
I actually want to create a book of literature, including all of the speakers. But something for November.
Thank you.
Thank you. Yes, I hope it wasn't too dense.
As the public.
But just the last point you made, where you started talking about emotional affect, and that's in a way the least explored, and for us, perhaps the most important. So it's opening up on an area of research and exploration that we deal with on an everyday basis. And again, going back to you talking about the physicality of listening and the relation between physicality and affect and emotion is so important, critical for the experience of adjusting these.
Yes, we were very surprised. I mean, and there is not much. There is actually a very interesting review by Charles Spence, who is an experimental psychologist, great work on understanding cross-sensory associations. So he did a review of research that tries to combine music with colors. And he basically arrived to the conclusion that there is no actually physical explanation or psychophysical explanation. There's nothing in terms of how we perceive colors and how we perceive musical sound that could explain some sort of cross-modality there. So, so what's probably going on, and he tried to support this with some of the evidence from some of the studies, is some emotion mediation. And that actually opens up a broader issue. I think I discussed that with some people yesterday. I think it was with you, right? There isn't a single mechanism explaining metaphor, right? So some of these metaphors could be simply learned. You have your teachers or your clients, the milieu you work with, the musical community you're affiliated with, and as you start getting embedded in that, somebody uses a term to describe a specific sound, and gradually in your brain you associate this description with this sound. And it's as simple as that. Other terms could be about emotion mediation. So connecting, I don't know, that's probably not the case, but it's the easiest example I can think of. Connecting high frequencies with brightness could be something that's mediated from arousal, for example, right? And then another scenario could be that some of these metaphors can actually come from innate things in our brains, like a priori, that somehow let's think of an example now. Again, brightness could be an interesting case. So anything that has high frequency, as is the bright sun, right? So the bright visual spectrum has more energy in higher frequencies, and then higher frequencies in sound and higher frequencies in vibrations. And so there could be a common representation for that somewhere in the brain. And maybe at some point we attach to it the label brightness because perhaps vision was more important at some point from an evolutionary perspective, and then that stuck with it, for example. A very interesting theory is Atom, a theory of magnitude by Walsh. So in that paper, I briefly presented the pitch brightness interactions. We actually also did brightness and visual brightness interactions, and we found some effects there as well. And we also tried to do some more abstract, but that didn't work. We probably need to refine our paradigm. But the idea is that I think somewhere here in the intraparietal sulcus, I think it's called, I'm not a neuroscientist, there is an area where the brain processes generalized magnitude. Anything that is more than or less than. So our ability to compare magnitude, like size, numerical magnitude, is probably innate and not modality specific. In this line of research, there were some experiments where they were showing digits. So let's say the digit 1 and the digit 3. And your task was to say which one has the higher value. And then they modified the brightness of its digit on the screen. So for example, you have 1 and 3, but 1 is brighter than 3. So there, they noticed, first of all, behavioral interference. So people became slower because somehow the brightness in the screen affected their thinking. And the error rate increased. And they were collecting magnetic resonances at the same time. And they found that this interference activated that area that is postulated by the atom theory for generalized magnitude. So that's one of the very few evidence that visual, at least, brightness can be a generalized magnitude thing. And that opens up a lot of interesting questions about then, what happens with auditory brightness, which kind of is borrowed from visual brightness. So we are trying to develop a new paradigm to investigate this with Zach Walmark. Not there yet, but we hope to.
I think we need coffee. I see the faces. Let's just thank the speaker. We can continue the discussion with the coffee break.
Yeah, we can.
We had climate change accident, and the plane from Tom didn't leave New York, so we don't have the talk and we don't have the workshop. So yeah, that's why I also let it go a bit longer, because at 12 we're going to be free. It seems. I mean, I don't get an answer from this, but yeah. So we can make the next talks a bit longer in the discussion, and maybe at the end have a bit of a round table feedback for the conference in general. And now just coffee, and please, the pastries, just have them over there, so there are no like shavings of butter crust. Thanks a lot.
Thank you. Whether
Avete bisogno di qualcosa?
Do you have the big version of the cover?
No. You want to say live for them?
Maybe this.
I can find you. I mean, I don't know what type you like, so I can help you. Good one. Do our best. Sorry?
Fire of some sort? Or
So this is like sensor for the microphones, and if you want to know more information about that, you need to ask where is it? Where is it? It's next to Rafa. It's on the column. You can ask him what is exactly it is. But it's pretty cool without any case, right? Yeah. Okay. Very cool. Yeah, ask him. Deve spiegare a lui cosa sono queste belle cose qui. Hi.
Paolo.
Nice to meet you. I'm just wondering what this is.
This is basically like we can do something better. They are not turned on, so we can show you.
It's only electronic.
Yeah, all the electronics is basically for communication. These are linear microphone arrays. They have, you can see there are some holes. They are 16. There are 16 microphones placed with precise distances, and this allows us, because I'm part of the Cremona lab in the Polytechnic of Milan, and we are basically the research topics are basically on two areas. One is the violin making and research on violins, and we will have the talk from Raffaele, which is one of our technicians. And the other part is space-time processing, basically. So we use this. This is a kind of tool that we use to measure and to acquire data, audio data, having not only the information about timing, because it has a standard audio file, but given the possibility to have a distribution of microphones, we can have the specialty information. This is one of the tools. The other one is that.
Oh, okay, yeah.
Yeah, it's a spherical microphone array, and it allows us to have different kind of information, but they are equally interesting as for the future processing and something and things like that. And,
So
yeah.
is there a particular chip that's is this the mic? Is that
Yeah, these are the microphones. They are actually maps. They are not very. The microphone in itself is actually not very expensive. I think it is around 500 euros or things like that. No. The whole assembly. Yeah. Più microfoni, sì. Più microfoni. They are made for. Interesting. This is a kind, and the other. This is actually the microphone is the same as the mobile phone. Sì, è lo stesso che si usa nei cellulari praticamente, perché l'idea era fare una cosa che fosse comunque abbastanza poco costosa da poter essere utilizzata, infatti noi ne abbiamo abbastanza di questi. Quelli lì invece hanno una qualità un po' più alta perché il microfono è più simile a quello che potrebbe essere il microfono da ripresa, però permette comunque di avere la spazialità, le informazioni sulla spazialità. Poi ci sono una serie di processazioni che si possono fare e ci danno sia le informazioni a vedere, diciamo, che poi da utilizzare per processazioni future. No, sono dei bei strumenti.
Something happened in my wallet. Okay, so are you planning to build a Leslie? Nice. It's very difficult. Well, you have to learn.
Very old
several techniques.
feeling that we have.
Our own technique, let's say, so where I have just an act
Really sensitive.
The art of manual making by Alfred. Some people are making this quite nice because there's a lot of historic memories, but at the end there's also this constructive metal with they quite wide and so they're very
As I say,
inflating. Yeah, I don't know how to say it. I'm exposed to something about strings from Germany. Yeah, that's a bit. Yeah, now we can read it. And then there was a guy that brought say it again. Good memory. I always say, oh yes, I will remember it after 5 minutes. But anyway, anyway, feel free to. That's also my mobile phone. Yeah, it's better than my phone. I have 50 messages. Yeah, I forget something.
Second, first movement of the Vivaldi sonata. Of course.
And the other movements.
Excuse me?
The other movements are faster.
Yeah, just connect your.
What is this? It's an array of mic.
I think we are.
Yeah, we're done.
We can do after the next two talks if you want.
Give me a time. Right.
Yeah, because we were a bit.
Yeah. It's a pleasure to introduce Martina Quintabala, who is you're a physicist, no? Yeah.
I'm an engineer.
Engineering, but you did your PhD in mechanical.
I'm a materials engineer.
Material science.
Yeah.
For optics, no?
Yeah. Yeah, I was working in optics at the point.
And then he makes mandolins now, as well as teaching in the. No, he's a professor.
No, the first one. No, not professor yet. Well, I don't know if I'll ever be, but.
At the University of Studio Ibérica. Beautiful city. And he's going to talk about free plates and flat plates
Mhm.
and plate tuning.
Yeah, play tuning in general.
Thanks a lot.
Okay, so thank you, Sebastian, for your introduction, and thank you everybody. It's a pleasure to be here. So I'm a postdoc researcher at the University of Bergamo, but I'm also a luthier, and I build mandolins specifically. So and I'm also building like carved top mandolins. So maybe it's a bit more similar to violins somehow. Okay, so well, don't be too hard on me if I'm saying anything bad for violin making. So I'd like to talk about plate tuning, and so I would like to start with a few questions. So most of you are most of us are makers. So do you tune plates? Who of you tunes the plates? Come on, you can raise your hands. Yeah, don't be shy. Okay. So second question, why?
That's a good question. Get a more repeatable result.
Yeah, to have a repeatable result, for instance. Okay. And how do you tune them? So do you have a method to do it?
Acoustic software.
Okay, clapping patterns and acoustic software. Modal tuning. Sorry. Harry's number. Okay. Okay, very good. And does it work?
Yes, sometimes.
Okay. Sometimes, yes. Does it work? Can you prove it works? I mean, can you measure that it works? Okay. Well, I mean, I'm joking, but I'm also serious. I mean, it's a problem I also see in my instruments, right? So
It should be the time you have to set it. If it's sold in 1 week, it's works.
yeah, it works. Yeah. That's a good answer. Yeah, for sure.
That's a good index.
That's a good index. If it's sold within 1 week, well, okay, plate tuning work. Yeah, but it's an interesting question, right? And for us makers, it's hard to experiment. It's hard to change a lot of the things because it takes a lot of time to make a violin or a mandolin. And so, well, we have to rely on something. We have some numbers, and often we rely on them, and things more or less work, right? So I'd like to talk about this plate tuning from a like scientific perspective. And well, basically, okay. So this is what more or less we said. We want to like tune plates to have consistent results, or maybe to replicate some tonal qualities that we found in like benchmark instruments or some instruments that we made before and we want to reproduce sometimes. So how do we do it together? Usually, well, we can tune plates, so carve them to achieve some, usually some frequencies of mode 1, 2, and 5. This picture is very famous from Caroline Hutchins. And sometimes if we get to the right frequencies and the right clapping patterns, we think that everything can go. Yeah, what's the physical basis of like plate tuning? Well, we start from like very simple systems like bars. Okay, a plate is not a bar, but well, let's talk about bars for a while. So a bar is something which is slender. It's small in section and usually long. And okay, it has one longitude. It has infinite modes of vibration, but we focus on the first one. This mode is called the marimba mode. Why marimba? Because if you like play marimba is made of bars, and this mode are tuned to play at a certain frequency. How can we tune a marimba, or how can we tune a bar? Well, if we know some physics, we can do it, right? And there's a simple equation for this first frequency of vibration that says that for a rectangular section bar, so very, very easy, very simple. Okay, not a violin, not already, not yet. Well, the frequency of vibration depends on something we know, probably the speed of sound, right? The higher the speed, the higher the frequency, and on the geometry, so on the thickness and on the length of the bar. So if we want to design a marimba, well, if we know the speed of sound, we can measure it somehow. And if we decide the length, then we can basically invert this equation and calculate the exact thickness for the marimba bar to play. I've done it with high school high school students, and it worked, and it was very fun to build a whole marimba this way. But, well, a violin plate is not a bar, right? Okay, it's a plate. A nice thing is that plates behave like bars, but like large bars. Okay, if you take a bar and you make it very large, it somehow becomes a plate. Let's say a rectangular plate. Some of you is very skeptical about this. Okay, a rectangular plate is not a violin-shaped plate. It doesn't have F-holes. Has a complex shape. It's arched. The thickness profile is not constant. Okay, but I'm an engineer, so I have to rely on some numbers, and I have to rely on some simplified models. A simplified model works, it's okay, and then maybe can represent some interesting aspects that are valid more in general, right? So we start from easy thing and then see if it works also for more complex things. Okay, so let's say we have a bar, and if we enlarge this bar, it becomes a very wide bar that has a marimba mode across the grain, right? But we can also think it as a bar which is widened this way, so it has also a marimba mode along the grain. Well, these are actually mode 2 and 5 of a plate, right? This is a violin plate, but if we consider a rectangular plate, we also have like these modes 2 and 5. Well, as I said, scientists want simple rules that can be verified. And once you have these simple rules, you can start to experiment with this. So a very first experiment was made by Schelling in the 1960s. Schelling made a violin model. He modeled it as a electric